Good evening, shadowy black figure here to talk you through esters today. Esters are the last of the main groups of organic compounds that we're going to have to name. There'll be one video after this on organic compounds, and that will be trying to get you through this week's worksheet. And this week's worksheet will have some quite intricate and complex molecules to name. But don't worry about that. The next video will give you plenty of help in naming and drawing those things. Don't worry about it too much, at least. So esters. What are esters? So before we start with esters, I just want to go back to what carboxylic acids are. And let's have a look at a classic carboxylic acid. We'll do this one. So here's a carboxylic acid. It is a COOH group, so COOH, which consists of a double bond oxygen, and without that hydroxyl group, it would be an aldehyde, and also an OH group, a hydroxyl group, and without that aldehyde group, it would be an alcohol. But both of them together make a carboxylic acid. So this one is ethanoic acid. And because these have been known for many, many centuries, they've all got common names, and those common names are still sometimes used. This, of course, is acetic acid. Okay, so here's ethanoic acid, rather badly drawn, I'm sorry about that. And with ethanoic acid, what happens is when you put it in water, it ionizes. And of course it gives off that H+, and what it leaves behind is a negatively charged ion, and that is no longer ethanoic acid because it doesn't have the acid, it's given that away, it's now ethanoate. So there's ethanoate. And this same pattern is followed with all of the carboxylic acids. So if, for example, we have this, and that's propanoic acid, there it is, propanoic acid, it ionizes in water, and it's now propanoate, or methanoic acid. That ionizes in water, and that's now methanoate. So be aware of this because this forms half of the naming of an ester. Now let's have a look at how an ester is formed, because this is the kind of reaction, it's a synthesis reaction, it's a kind of reaction that will be well known to you if you've ever studied any biochemistry, because it's by this form of reaction that things like polysaccharides are formed from monosaccharides, or let's say a dipeptide is formed from two amino acids. So let's have a look at this, where a condensation reaction forms an ester. So we start off with the ingredients, and the ingredients are a carboxylic acid. There obviously was a reason for doing that. And here's our carboxylic acid. You'll notice it's got 4 carbons, so you'll be aware that it's butanoic acid. And on the other side, we'll put the alcohol, because of course an ester is a combination of an alcohol and a carboxylic acid. And we haven't got much room, so we'll use our old friend ethanol here. So we've got butanoic acid and we've got ethanol. Now this is a condensation reaction. So with a condensation reaction, you'll be aware that condensation means production of water. And if it's production of water, then you're going to have an H2O molecule given off. And if an H2O molecule comes off, then somewhere has to give away 2 H's and an O. And basically, you know what a carboxylic acid does when you put it in water. It ionizes. It will give that away. It will give that hydrogen atom away. And if you combine that with the hydroxyl group of the alcohol, then that forms your H2O. And when we take that H2O away, like this, we get just a little oxygen left, joining those two things together. And it looks something like this. And so we get an ester. Now notice the way you tell an ester is that it's got an oxygen atom here in the middle, just as if it's an ether, but you also have that double bond oxygen coming off the side, like maybe an aldehyde, but now it's in the middle of the chain, so maybe a bit like a ketone. But together, they don't make an aldehyde, a ketone, or an ether. They make an ester. And if you see this combination of an oxygen in the chain and a double bond oxygen off to the side, you know that that's an ester. Now let's name this. When we name it, let's see. This used to be ethanol, but it's not anymore. It's lost its OH group, it's lost its hydroxyl, so it's no longer an alcohol. It's simply a functional group, an alkyl group with 2 carbons, so it's ethyl. And then we get this thing, which was butanoic acid, but now has lost its hydrogen, so it's no longer an acid, it's an ion, and it's butanoate. So there we have ethyl butanoate. And this is quite an important molecule because it's what gives bananas their taste and their scent. So the esters are quite important in food chemistry. The reason they're quite important is because each different ester is likely to give a fruit its characteristic smell and taste. So here's bananas, ethyl butanoate. And when you do food chemistry, you'll probably labour long and hard to synthesize these and put them in a recipe in some sort of maybe candy or dessert, because it's a whole lot easier just to add some esters than to fiddle about with fruit juice. Fruit juice is expensive, it goes off, it's perishable, but esters don't. So if you just have your esters and you add those to your candy recipe, then it smells of banana, it tastes of banana, and therefore it's a lot easier to work with than mucking about with real bananas. Let's do another one. Let's do a hex now. So here's a hex, and you can immediately see that it's hexanoic acid. Right, and I'll just add this. And it's our old friend ethanol again. It's such a stable molecule. This ethanol occurs in quite a lot of organic chemicals. By the way, plants can do this sort of reaction, this condensation reaction, very readily. And that, of course, is why plants do produce fruits with these characteristic ester tastes and smells. So with this one, immediately we can see that it will ionize, and therefore it will give away that hydrogen, well, now an ion. And here, the ethanol will give away its ol, its hydroxyl, and they will go away and become H2O. Okay, so once that happens, we rub them out, and then we've got 2 carbons left with their attendant hydrogens, and we add those to here. And then we've got, well, we've got hexanoate and we've got ethyl. And because the name of these always starts with what was the alcohol, it's ethyl hexanoate. And this is one of the chemicals that gives pineapples their flavour. It's not the only one. Pineapples are quite a complex little bunch of biochemistry, and so they have all sorts of other molecules that are contributing to that distinctive flavour that we recognise as pineapple. All right, so let's have a look at this one down here. So I've had it there because I'm so bad at drawing hexagonal molecules. This is benzoic acid. Let's make it into benzoate. All right, so this is benzoate. And you'll be aware of something like sodium benzoate maybe if you've looked at any food labels, because sodium benzoate is a very, very common preservative for foods. And so you'll see that on so many food labels. That's simply what it is. It is an, let's see, it's not an ester because it's added some sodium to it, a sodium ion. But let's make an ester out of it. So I'm going to do ethanol again. Forgot what I was doing for a moment there. And as usual, The benzoate is now benzoate, it gives that away. The H and O from the hydroxyl group go away, and an H2O goes away because it's a condensation reaction. We draw those closer up here. Get rid of that. And now, ethyl benzoate. So whatever it is, you just follow the same rule each time. The alcohol loses its hydroxyl group and goes first. So if it were heptanoic acid, if it were heptanol, it's now heptyl or heptyl. If it were decanol, it's now decyl or decyl, and that goes at the front. And the other one, whatever the carboxylic acid was, it's now no longer the carboxylic acid, it's the carboxylic OH. And so if this were, I don't know, heptanoic acid, it would be now heptanoate. And there's a whole lot of these. I'll just finish because I can't remember them all. Apple is ethyl pentanoate. This one is cherry, ethyl benzoate. Honey is butyl ethanoate. And so many of the common flavors and smells of foods that you're used to are actually due to a high concentration of one or another ester in the chemical makeup of that fruit or that food. Thank you. Bye-bye.